So that formula, the dot product, oh, it's V and W. The dot product of both of our vectors over the length of both of our vectors. So our vector V, I'm going to write it out like this, 3, 2, 1. And our vector W, 4, negative 1, 2. Our dot product is going to be 12 minus 2 plus 2. The length of V will be 9 plus 4 plus 1 times by the length of W will be 16 plus 1 plus 4. So we're going to get 12 cos of theta is equal to 12 over root 14 times root 21. And cos inverse of 12 divided by square root I got my angle to be in radians, decimal 796. Did anybody do it in degrees? .6 degrees. Now, with 2 dimensions, would that be a second angle? You could have many different angles that would solve that solution, but as far as when we put vectors together, we're either going to, because there's a direction to them, if you found the bigger angle, you would be finding this one. That would be the second answer. Since cos is positive in 1 and 4, right, there's going to be an answer of 314.4 degrees. But when we're finding the angle between two vectors, in this case, it's going to make sense to find that angle, the smaller one, rather than finding the big one that goes around the outside. So we're always going to find either the angle between 0 and 90 degrees or the angle between 90 and 180. If you found the other one that would work, it would just be the outside angle as shown here. Now, what I find is really fascinating about this is if we would imagine drawing this in 3 dimensions. So here's our x, our y, and our z axes. 3, 2, 1 would mean going over 3 in the x, 2 in the y. So that would get us to this point and then move us up 1. That would be that vector. And 4, negative 1. So 4 to here, negative 1 would get us back to there. And then up 2. 1, 2 would be that vector. And we were able to figure out what this angle was in between those two. Now, you could work with your 2-dimensional geometry and 3-dimensional geometry and figure out lengths of that triangle and figure out how far apart those are to make a triangle and figure out that angle using your cosine law. But can you see that that would feel like it would take a little bit of effort? We could do it, but the vector dot product for this works really, really nice.